Welcome back to the Deep Dive.
Hi there.
Today, we're going into something, well, pretty unexpected.
Oh, yeah.
We're looking at this surprising link between a 13th century philosopher and the artificial intelligence we're building right now.
Wow, okay. That's a name I didn't expect to hear alongside AI.
Right. Thomas Aquinas, from hundreds of years ago. But we're going to dig into how his ideas are actually kind of foundational for modern AI systems.
Okay, I'm intrigued. So our mission today really is to unpack that, how Aquinas's way of thinking about organizing knowledge, these hierarchies,
Yeah.
how that basically provides a blueprint for what AI developers call formal ontologies. And we'll look at what that means for how AI learns, how it handles information, and, how it figures out the world.
Okay, let's unpack this then. Thomas Aquinas, 13th century. Artificial intelligence, 21st century. How on earth do those connect? It feels like a massive jump.
It does. It really does. But what's kind of amazing is that this basic principle of sorting knowledge, starting broad and getting specific, it's so fundamental it seems to apply to intelligence itself.
Whether it's human or artificial.
Exactly. Whether it's Aquinas wrestling with big theological questions or an AI diagnosing a medical condition, the underlying structure for understanding seems remarkably similar. So Aquinas had this model separating the general, the abstract, from the concrete, the particular details. And that's almost a perfect mirror of how these formal ontologies in AI are designed hierarchically.
Okay, so an ontology is like AI's internal library system.
That's a great way to put it. Yeah, meticulously organized. It categorizes everything it knows, from the really big subjects down to tiny details. And AI uses this structure, this hierarchy, to figure out relationships between things.
Between different areas of knowledge.
Between different domains. And that lets it classify stuff, find information. It makes it really effective.
That is genuinely surprising, that echo across centuries. So if we take that core idea, the hierarchy, how does AI use it today, to actually deal with our messy, complex world?
Well, one of the big goals, connecting it back to the real world, is achieving what's called interoperability.
Interoperability, meaning?
Meaning making sure different AI systems, or even just different parts of the same system, can understand each other, can share knowledge because they're using a compatible structure.
So they can talk to each other effectively.
Exactly. As Vadinsky pointed out, this is crucial if AI is going to function properly in our very interconnected world with all its diverse parts.
Okay, so we have the basic structure, the why. Now, let's get into the how. How does this abstraction, this sort of top-down thinking, actually work inside an AI?
Right. So think about Aquinas' chain of abstraction. AI uses something very similar. It builds up layers of classes, general features, to identify specific things.
Okay.
And this allows for what's called semantic interoperability. A good example is medical diagnosis again.
The AI isn't just seeing isolated symptoms like fever or cough. It understands them within a larger framework. It moves down through these layers of knowledge, general categories of illness, potential causes, to finally arrive at a specific diagnosis for that patient.
So it's reasoning from the general to the specific based on the evidence.
Precisely. It's trying to derive conclusions from symptoms, kind of like how a human doctor thinks through a case.
And this isn't just static knowledge, right?
Yeah.
AI needs to keep learning,
Updating things constantly.
Yeah.
How does a hierarchy help there?
Exactly right. Things change. So AI systems need ways to search through their knowledge and, crucially, modify it.
It saves repeating information.
got it, and subsumption.
Subsumption just means one concept is naturally included within another. Like the concept dog is subsumed under the concept mammal. It defines the relationships.
Okay.
And you see this in action in things like expert systems.
Right, those AI programs designed for specific problem-solving tasks.
Yeah. They learn the rules for their domains, say identifying machine faults, by using these generalized concepts within that hierarchical structure. And having this clear structure has big advantages for reasoning. It makes the AI's process more transparent, more modular, easier to manage.
Makes sense. But what about growth? Can these systems actually scale up effectively? The real world keeps getting more complex, data keeps exploding.
That's a really key question. And yes, the ontological hierarchy is actually pretty good for scalability. You can add new classes, new concepts into the structure without necessarily breaking everything else.
So it builds on that idea from Aquinas about balancing how wide your knowledge is versus how deep it goes.
Kind of, yeah. This layered structure, this taxonomy, is what lets AI systems break down problems, update information in specific places, and find what they need efficiently.
Can you give an example of where that scalability really matters?
Sure, think about multi-agent systems.
Yeah.
These are systems where you have lots of different AI agents working together, maybe coordinating traffic flow or managing a power grid.
Right.
They need a shared understanding, like a global map of the domain knowledge. This hierarchical, scalable structure
Lets them maintain that shared map and easily add new information as the situation changes.
So it's clearly more than just, like, filing data away neatly.
level, but your brain very quickly turns that into higher level concepts, symbols. You don't just see pixels, you see a chair, or recognize a friend. AI tries to do this too, integrating the low-level sensory stuff with a high-level abstract knowledge.
And that helps it react better in dynamic situations.
Exactly. It enhances its response. Take AI used in conversations, chatbots for example. This layering helps them perceive what's being said, reason about the meaning, and adapt to the context of the dialogue as it unfolds.
Context is so important.
How does the hierarchy specifically help AI manage different contexts? Because the same word can mean totally different things depending on the situation, right?
It's Now, locality is about efficiency. It's like when you're fixing a bike, you don't need to access your knowledge about, I don't know, 18th century poetry.
Hopefully no.
Right. You focus, you localize your thinking to mechanics, tools, bikes. AI does the same. It limits the scope of information it's processing for a specific task. That saves computational time and resources. It's much more efficient.
So it zooms in on the relevant knowledge layer.
Exactly. And these contexts can be layered too. You might have a broad science context and then a more specific physics subcontext and maybe even a quantum mechanics subcontext. Each layer narrows the focus.
Interesting.
And there's another layer too. Sometimes a metadata layer is used. This can help with things like natural language processing, understanding the nuances of language. It helps the system stay aware of the current context, reason better with just the relevant facts, and importantly, avoid contradictions.
So new knowledge can refine things without messing up the whole structure.
That's the idea. These layers can extend or refine each other without forcing a complete overhaul of the AI's global knowledge base.
Okay, this hierarchical approach sounds incredibly powerful, like a really well-organized brain for AI. But surely there are downsides. Where does it struggle?
Oh, definitely. It's not perfect. There are significant criticisms. One big one is that these systems can struggle to represent information or relationships that fall outside their predefined categories, their taxonomy.
So something doesn't fit neatly into a box?
It can be a problem. Kim argued that hierarchies can be limiting, especially if our understanding of the domain isn't complete when we build the system. We might miss important connections. And specifically for cognitive AI, trying to mimic human-like thinking, there's a real challenge in keeping the symbolic layer, the abstract concepts consistent with the subsymbolic layer, the raw sensory data.
Especially when new data comes in that conflicts with what the AI knows.
Exactly. Handling that conflict in real time is tough. Often you need special interfaces just to manage the potential inconsistencies between those layers.
Okay, what about things that are inherently messy or unpredictable? You mentioned emergent properties earlier, like a flock of birds. Can these neat hierarchies really capture that kind of phenomena?
That's a great point, and it's another area where Kim, for instance, raised concerns. Hierarchical systems often struggle to fully represent emergent properties.
Because the flock's behavior isn't just the sum of individual birds flying.
Precisely. It has qualities, patterns, collective level, and capturing that kind of dynamic interaction.
That collective behavior that seems to arise spontaneously is hard to do with a static, abstract hierarchy.
It's like the structure is too rigid.
You could say that. It's partly an not necessarily ditch them, but maybe supplement them. Kim suggested incorporating non-hierarchical approaches, things like non-linear models, feedback loops, systems that are good at capturing those dynamic, sometimes unpredictable interactions. The idea is to expand the AI's toolkit for understanding.
Right, give it more ways to represent reality. So pulling this all together, the power of hierarchies, the limitations, what does it mean for the future of AI? Especially for its ability to truly reason and make novel connections.
Well, this leads us to an interesting concept called deep reasoning. Even with their limits, hierarchies are still seen as really valuable for cognitive AI, partly because they're modular, as Sloman pointed out.
Modularity meaning?
Meaning you can have specialized components within the broader system. An AI could have deep expertise in one area, but still be able to access and use knowledge from other areas by moving around within that hierarchical structure. This actually helps with transparency. You can trace how it reached a conclusion.
Okay, so what is deep reasoning itself?
Deep reasoning is essentially the process of making inferences and drawing conclusions by moving between the different levels of abstraction within that ontology.
So not just reasoning within one level, but jumping between the general and the specific.
Exactly. Moving up to broader concepts, down to finer details, connecting information across different levels. It allows the AI to derive new knowledge, make connections it wouldn't otherwise. It's kind of emulating how humans shift their focus, zoom in or out to understand something complex.
What an incredible journey we've taken today.
Yeah.
Seriously.
Yeah.
From Thomas Aquinas back in the 13th century,
Yeah.
all the way to the core structures that let modern AI classify information, learn, handle context, and even engage in this deep reasoning. It's mind-blowing, really, how these philosophical ideas echo down the centuries.
It really is, and it leaves you with a pretty provocative thought, doesn't it?
Go on.
Well, if these hierarchical systems are great for structured knowledge, but, as we discussed, struggle with the unpredictable, the emergent, what does that imply for where AI design needs to go next? Could it be that to build truly intelligent, adaptable systems, we need to fundamentally rethink how AI represents knowledge itself? Maybe move beyond these more static structures towards something more dynamic, something that can constantly evolve its understanding of the world.